All right, that's great. So we're going to talk about this from the beginning, but this is a modified Atwood machine. So I've got this. This is the unbalanced force. That's the only thing that causes the system to move. Put your hand down, please. Unless it's a procedural issue. I don't care. I'm not touching anybody's paper. So if you can't make it work, go out in the patio. That doesn't work, I don't know what to tell you, but I am not collecting a piece of paper anymore. All that happens is I put them someplace and wait till I feel like I can touch them in a couple days, and then I get a deluge of messages about why it isn't graded yet. I'm just not going to touch them. Can't bring myself to do it now. So, all right, what I was saying. Let's talk about this problem. This one right here in front of us. The whole system moves, or at least that's what we want to have happen. All three boxes. That's why their inertia is in the denominator. But the thing that causes the system to move is the one box that's hanging off the edge. That's this problem. Is there any surprise that that's the problem? Does anybody not understand that that's what's happening? Are we sure? Because I don't want to come back to the idea that that's not what's happening. So, does everybody understand that the top box accelerates? The bottom box accelerates. The top and bottom box accelerate at the same rate. And they accelerate at the same rate as the box hung off the edge. That this is how fast they accelerate. Now, you might not know where that comes from. So let's make sure that we have all the pieces together, because I don't want to make too much of an assumption here. I'm going to assume this is the direction of positive. Any problem with that? All right, good. So this box experiences two force. Weight downwards, tension upwards. Any surprises there? Don't want to pull a fast one on you. Okay, so we can state that mg minus tension equals ma. That's good? All right. I don't have to talk too much, I don't think, I hope, about the fact that the tension on one side of the pulley is going to be equal to the tension on the other side of the pulley, because in this problem, the pulley is massless, so I don't need unbalanced tensions. That's okay? So that means that there's going to be a tension on the top box. So let's look at the forces on the top box, because we have several. There is the, need to write a little bit lower so I don't run out of screen. There's weight downwards, little mg, normal force upwards, sure. That normal force is what causes the frictional force, which on this box is this way, trying to prevent it from going forward. And there's tension this way, which I'm intentionally drawing greater than the friction because this box accelerates. In fact, when I consider the forces on this box, tension minus friction equals ma. Net force in the x direction has to equal ma. Question about that? Are we sure? I'm confident I have people in here who wrote tension minus friction equals 0 because it's static friction. If that's you, don't wait till tutoring to ask why. Okay. So normal equals weight. The 3M box has a variety of forces acting on it. Only one that matters. I don't care about any of the up or down forces. They do nothing to that box. I mean, yeah, I get it. There's the downwards normal force from the box above it. There's the downward force of weight. And there's an upwards normal force from the table. None of that matters because there's no friction from the table. But there is a frictional force sideways. This is the Newton's third law of force, the internal force between the two boxes that keeps them stuck together, prevents one from sliding past the other. Now, that suggests that friction equals 3ma. Let's pause here because I really don't want to wait 5 minutes to find out that you didn't understand one of these pictures here. But I also want to point out that I've not done anything outside of our set of steps that starts with, is there anything touching the box? Any questions?
Why is friction to the right on that box?
Well, the top box is trying to scrape past it. In what direction is that top box trying to scrape past it at?
The friction's going to the left, but so it'll move right.
When I'm looking at this interface, as this box attempts to go to the right, it must push on the bottom box to the right. Is that okay, or is that not really working for you?
No, that's good.
Okay. Now, ultimately, you might not know what to do next. However, I suggested to you that we consider pressing on and eliminating all of the internal forces. I have said those words, that when you reach this point, you may not know what to do next, but you have a set of relationships, and these relationships all share some common variables, A, F, and T. You could press on. You could eliminate all the internal variables. This will produce for you, very likely, an expression of the acceleration or something similar. Whether that's going to be useful to you or not doesn't matter, because some of you just need a place to begin, and that's a good place to begin. So try it. Eliminate some variables. I encouraged you to plug everything in to the nucleus, the one that has all the forces in it. So that would be this one right here. When you do that, you'll need to get tension from down here. So tension is going to be equal to mg minus ma. Plug that in. Minus friction. So friction is equal to 3ma equals ma. Lo and behold, I have an expression for the acceleration. That's in terms of just all the masses in g. It's not particularly exciting, but there it is. mg equals 4ma plus big M A. I mean, one more bit of factoring. Net force equals inertia times acceleration. I mean, this part shouldn't be a surprise anymore. It's been on every single practice we've done for actually the last 4 weeks. So we get there. I don't know if that's useful or not. All I'm doing is following through with the set of steps that we've had, making one assumption and only one, that the whole system accelerates together. Not a bad assumption, since that's what the problem said to do. Now the condition. What does it take for this to happen? Well, I'll tell you what it takes. It takes the friction to be less than mu times the normal force. That's what it takes. That's the condition. It's static friction. So you need to figure out how to work this condition in. But even that shouldn't be too terrible. I have an expression for the normal force. So I know how big I need to stay under. And I have an expression for the frictional force. So I know what the size of the frictional force must be. Substitute into your conditional. Those words been spoken? Yes, a lot. I know, though, this has A in it. Lucky for us, we have a way of using something else to represent A. This page is kind of messy. It's not particularly great, and I'm kind of out of space. So either it shrinks up or I go to another page. It shrunk up. Good. We'll put that right over there. Tuck it in the corner a little bit. Maybe not. Maybe we'll tuck it into the corner this way. There we go. I want to be able to see it. There we go. All right. So let's parlay this into an answer. So I'm going to combine some things. 3m times, and this is going to be big M G over 4m plus big M. Has to be less than or equal to mu mg. All right, all of you people who had question number 2, your problem is largely done because I can cancel out the m and the g, giving me 3m over 4m plus big M must be less than or equal to mu. Look, it's great too because it says that the coefficient has to be greater than or equal to this stuff. How convenient, it's greater than. Suggesting that I need to make my surface at least this sticky or better. Seems like a reasonable thing. Of course, if you had question number 1, sorry, but you weren't done. You have to do some more work. Your problem was a little bit longer, which is why I gave you that extra minute, because you have to do this. You have to do this. You have to get the things on the same side. I know this is tough stuff, but I want to make sure that I'm at least being as condescending as possible because I am a terrible person. And then factor and divide. I don't like it written like that. I'm going to grab that little M and put him out front. Boink. Put that in parentheses. I like that better. I like that much better. And look, lo and behold, this mass has to be less than or equal to this. I mean, I can't put anything too big over there. I need to keep it smaller. Smaller than whatever this works out to be. Now, you guys unfortunately have to deal with the fact that I've already lost all my patience. So all my happy thoughts left right about the end of 4th period. Not because of them, but because I just was done. At the same time, I get frustrated when I tell you to consider something. And I mean, I talked about this earlier in the week. Do you know how many of you brought your question about this up to me and asked? I didn't get how to do that. That's the exact number that did. That's right. I said, consider what would happen if you put the string on the top block and not the bottom block. That was Monday when we were doing the other one where it was on the bottom block. So, yeah, I expected a lot more success. I expected, to see better things here. I'm a little sad. And the worst part is, you guys think, well, actually, I don't know what you think. I think some of you think that it's just you. You don't understand. I think some of you think, well, I can't believe I made that mistake. Or some of you, I have no idea what you did, Mr. Shelton. And I don't know which is which is why you uploaded your document for me. You notice you're not grading it right now. And I don't want any thank yous, but you should probably consider that. You know, a little bit of grace. But I'd say two things. I'm pretty patient as a person goes, but come on, I told you to think about this problem. I told you, please consider it. I gave you 3 days to consider it. It should have only been 2 days, but yesterday was a little bit unusual, and I was unwilling to give you a quiz yesterday. But come on. The least you can do is, take me up on something when I offer it to you. Homework wasn't so bad. This one's not so terrible. At least not so terrible now. If your notes are of no use to you, you need some help with your notes. They should be helping you figure this out. Now, if all you made was a couple of algebra mistakes, I don't care about algebra mistakes. But if you full on didn't know what to do, that's going to be an issue. So, are there any questions about what we have talked about to this point? For we are not done. I worry because tomorrow's Friday. What did I say we would do on a Friday? I know. I don't even know what to do next on Friday. So we're going to pause this for just a minute. Yes, it is. It's funny that's called a meeting. I don't think we're meeting about anything. All right, so I have a very low friction here, not connected to anything. Okay, there's a string there, but it's not connected to anything. I put one of these little boxes on there, and it's got a wood surface on one side, and it's got a felt surface on the other side, but it is inside the container, so it goes wherever I want it to go. Does that make sense? It's not going to slide off. But this little sucker is connected to the weight that if I'm going to sign, I did not hang a big weight because if you look at that fraction, you'll notice that that fraction suggests that the weight that you hang has to be small. There is some math in there. So I've made a small weight here. And also part of that has to do with how much acceleration I want. And I don't want that much acceleration. For if I have too much acceleration, I tend to break things. So I've set this up so that I'm hoping I have a system here where there'll be enough friction to, not separate the blocks. Of course, until I reach it to the end. And I wanted to make sure you saw that it does separate when it makes it to the end. Part of that is because the force I have over there is actually greater than the frictional force, at least the maximum frictional force. But when the system is allowed to accelerate, the tension is a bit reduced. The friction isn't so great that it won't accelerate. Now, I can reduce the frictional force by using a different surface. So this problem is different. And I want you to understand, I'd like to talk about this problem. Because you see that, right? You see both cars are accelerating, or at least both objects are accelerating. But do you notice that they're both accelerating at different rates now? You see that, right? Both of them, they accelerate though. One more time here, because this is the level of the AP exam. The fact that both boxes were accelerating, but not at the same rate. Now that problem has some things that are easier to deal with. The kinetic frictional force is a constant, not an inequality. Once I broke friction, that force is going to stay the same no matter what the accelerations were. But again, the problem I'm beginning to see is people are having difficulty getting this problem done. But everything here accelerated at the same rate. So there it is. There's the problem. You do notice, though, that I'm right at the breaking point. So I don't have much more to go on. I could lower the friction even more, but what's the point of that? The felt on felt should be really low. We'll see. Nope, felt on felt must be higher. Wood on felt, though. Oh, must must be this particular bit of, oh, I know what it is. They sprayed the room and the felt side was up on one and down on the other. So the one got all that chemical on it. You gotta love that too. So there it is. There's your, oh, one of them stay. One stay. Stay. All right, so there you have it. That was the quiz today. Now, if you didn't get a perfect quiz, I'd like you to do better. And like I said, I don't have the patience to tutor anybody today. So there won't be tutoring today. I'll be happy to tutor some folks in the morning. I'll be available tomorrow morning, even on Zoom, starting at 8. But I can't do it. So practice, please. You have homework. I can't tell you what the next situation is going to be. The homework has a lot of fun questions. And I use the word fun tongue-in-cheek like. There's a lot of those questions that have, a box attached to the wall and a box underneath it, and there's friction in one way, friction. Try those. Clearly the direction of friction gets to some of you. I know that the idea of static friction introduces that inequality, and that can be tough. So rise to the challenge and do it, be better. Check your textbook. There's a dozen examples. There's a dozen examples in the textbook. Try those. Cover up the solution, work the problem, peel the sticky notes off, and check your work. All right, goodbye. Have a nice day. You guys at home, have a wonderful day. I'll see you all tomorrow.
Bye, Mr. Shelton.
Bye-bye.
Mr. Shelton.
See ya.